In this video we're going to look at an example of using a formula with a square root in it to solve a real life type of problem, a story problem. So let's take a look at what we've got here. The length a spring is stretched from its natural length with work W foot-pounds is given by L equals the square root of 2W over K, where K is a constant for the given spring. Okay, let's talk about that for a minute. So what we're going to do is we've got W is foot-pounds, so that's some kind of weight or pressure that's being used to stretch this spring. And L is the length that the spring is stretching from its natural length. So the length a spring is stretched from its natural length. So picture like you have a spring, you know, like this, and it's just sitting there, nothing's pulling on it or stretching it. And then you get some W foot-pounds. I guess I could have drawn it this way, like this. And then you get some pressure, some W foot-pounds pulling down on it. So now the spring is going to go, oops, you know, it's going to get stretched out farther. And so this distance right here that spring is being stretched from its regular resting length is L. Right? The length the spring is stretched from its natural length. So this is sort of like the difference in the lengths of the spring from its natural state versus when it's being pulled with W foot-pounds. And this is the formula for that. Now we have another variable in there besides L and W, and that variable is K. And K is a constant for the given spring, and that's a little bit tricky. We're going to be given that number in this problem, so we don't have to worry about it. But each spring will have a different constant depending on what it's made of, and you know how thick it is, and how tense it is, and how easy it is to stretch, and stuff like that. So that constant would be figured out from doing tests. You could put a certain number of foot-pounds on the string and measure how far it's stretched, and then put another amount of foot-pounds and measure how far it's stretched and do some computations and figure out K. But that's already given for us, and we don't really have to worry about that in this case. There may be some other story problems where you actually have to figure out K, but not today, not this one. So basically it's just a matter of plugging in values, but I wanted to take the time to go over the formula because anytime you're working with a formula, you really need to understand what all the variables stand for before you start, so you make sure you put the numbers in the right spot. Alright, let's continue reading. If a certain spring has a constant of 32.9, so what's that 32.9? Is it K? Is it L? Is it W? It has a constant of 32.9. Alright, hopefully you said that is K. That's where we're going to put the K value. That's what we're going to put in for the K value, 32.9. And the spring is to be stretched 1.2 feet from its natural length. What's the 1.2 feet? L or W? Hopefully you said L. That's the length that it's being stretched. And the question is how much work will be necessary. So that's what we don't know. We don't know the work. We're not going to know W. Anytime you're, solving, working with a formula, well, especially if you're like in a beginning algebra class or an advanced algebra class, if you just have one equation or one situation, you're going to need all your variables. You're going to need to know what they all are except for one. So in this case we have 3 variables. They're going to have to tell us 2 of them in order for us to figure out the other one, and they did. Okay, so here we go. We're going to plug in the 1.2 for the length. And we're going to have the square root, and we've got the 2. Now we need to times that by W, but we don't know what W is. And then we got to divide that by K, which is 32.9. Now at this point, I don't really care what the story problem says anymore. I'm solving for W. That's all I'm focusing on. And if you watched the last videos about solving radical equations, you know the first step is to make sure your square root's isolated on one side of the equal sign, which it is, so we're good to go. Second step, you remember what to do next? Hopefully, you're saying square both sides because we need to get rid of that square root. So 1.2 squared on the left-hand side is going to be 1.44 because 12 times 12 is 144. So you got 1.2 times 1.2, just move your decimal 2 places. On the right hand side, it's a lot easier than it looks. Remember that the square root and the square just cancel each other out, so basically you just drop the square root and you end up with the meat and potatoes inside that square root, the 2w over 32.9. Now we're just going to solve it by getting w by itself. I'll take 2 steps to do this. You could do it in 1, but let's multiply both sides by 32.9. So we got 1.44 times 32.9. That equals 47. Let me write it up over here. 47.376 equals, and these cancel, 2w. Almost done. Divide both sides by 2. And we get w equals 23.688. So now we should go back and make sure we've answered the question. How much work will be necessary? Round your answer to the nearest tenth. Okay, tenth. So the tenth is one place after the decimal. I'm going to have to cut it off right here. And that 8 will round that 6 up. So to the tenth would be 23.7 foot-pounds. So that would be the amount of work that we would have to apply, 23.7 foot-pounds, to this spring in order to stretch it 1.2 feet. Read through the problem, figure out which number goes with which variable, plug it in, solve for the other variable, check your answer, round it appropriately, and you're good to go.